my friends, here we are going to study about our second three-dimensional figure called a cuboid. Sometimes it's also named as a rectangular parallelepiped figure. Now, in the previous article, we have studied about the cube, how to calculate the total surface area and a volume of a cube by using art of mensuration. Now, you are aware of the art of mensuration. What we do to calculate the total surface area? With the help of scissor, we cut all its sides. Okay. Because of which is hollow inside, we get flat surfaces, and if you cut these all sides and you fold it, then it will just look like this. Okay. Now here, first of all, we'll carry about the naming to the corner. You know what type of structure it is? It is called a cuboid. What type of cuboid structure it is? It is just like a brick, construction brick. The construction brick is just like this. So a brick, construction brick and a cuboid, they have same type of shape. For construction brick, it has here length. Here length is there, and this is breadth, and this is height. This is height of our brick, length, breadth, and height. It is not like a cube. In cube, the length, breadth, and height, they are of equal length, but here it is not. Now here, let us carry out the naming so that we can systematically study and find out the total surface area and volume of this cuboid. Here, let this corner is again A, this corner is B, this is C, D, E, F, G, and H. Now, if you cut it and you fold it, then it will just look like this. Where will be the side like previous cube? Here you will get the base here. Here you have the base. So I will name this base as, like previously, H. Here G. Then here you will get F. Here this is F, and here it is E. Here you will get A dash, B dash. Then here you will get AB. And here you will get DC. Here again you will get D, and here A. Likewise, here you will get B, and here you will get C. But after that, after folding, cutting and folding, like this shape you got, and if this shape you will flatten it on the ground, it will just look like this. So now here, first of all, in case of this, in case of this cuboid, this is called as E to F. I mean EF, EB, DC, and HG. These are long sides, so we call them as length. So first of all, I will take this as a length. I will call it as a length, this to this. Okay, so I will write it as L. Similarly, if you consider the F to G, then we call it as a breadth. I will denote it by letter small b. And this is C to G. C to G is a height. So I will denote it by letter H. Now, can you say in this flat figure, which you have flattened on the ground, which is length, breadth and height? First of all, this is length. Okay. This A dash, B dash is a length. So all these are length. A, B, D, C, H, G, E, F and A dash, B dash. Length of all this is equal. So that is L. And where is the breadth? Here F to G is a B. So F to G is a B. So this length is B and this length is B. So here you have to take it carefully that which should be breadth and which is length and which is height. To which you call it as height, C to G. C to G, this is height. This is height, and here likewise here H to D is a height. And again, what you can say about this DH? If you observe towards the figure, then DH is here, it is height. DH is height. Okay, that's why CG is also height. CG is equal to DH. That's why DH is height. And what about AD? AD is breadth. AD is breadth. So here I will take it as breadth. What about A dash E? It is A dash E. Here it is height. So again here I will take it as height. Now here we will calculate individually the area of each type of rectangle. As length, breadth and height they are of different length, we will calculate the area of each of this figure. So first of all, we will calculate the area of ABCD, and I will call it as area number 1. I will call it as area number 1. So here, while calculating area of rectangle ABCD, what will be its area? So I will name it as area number 1. And it is equal to length into breadth. What is its length? L into length into breadth. So L into B. This is the area of our rectangle ABCD. What you can say about the area of this second rectangle? It has the length L, which is common, and breadth is equal to height. That's why we can say that area number 2 will be given by, how you will find out the area of DCGH? That will be equal to this length L multiplied by height H. Like this. Likewise, how you will calculate the area of this base rectangle? In the base rectangle, I will call the area of base rectangle A3. And this is length and this is breadth. So its area will be length multiplied by breadth. Okay. Now what is left? Area number 4. Here I will calculate the area number 4 of this rectangle and call it as E4. What will be the area of this rectangle? This is length. So length multiplied by this, in place of breadth there is height. So I will write it as H. Now only 2 rectangles are there, this and this. Now can you say what is the area of this rectangle? I will call it as number 5. Okay, here I will write. of number 5, the area will be equal to A5. I will call it as A5, and it is equal to, this is breadth and this is height. That's why its area will be equal to B multiplied by H. And what about this? Area of this is also, one side is B and other side is H. So area number 6 here, area number 6 is also equal to B into H. This is also equal to B multiplied by H. Now let us calculate the total area. Okay, individually if you take the area, the one by one, then you will get total surface area at what? Total surface area, total surface area of cuboid. Total surface area of cuboid, which is denoted by letter ST of cuboid. Therefore, here I will write as ST is equal to what is area number 1. One by one, right? Area number 1, your area number 1 is equal to here L into B. That is, so I will write L multiplied by B. What about area number 2 here? That is plus L into H. Got? Now again plus, what about the area number 3? That is L multiplied by B. Okay, and plus again, what about the fourth area? Area number 4 is L into H. L into H. What about area number 5? Your area number 5 is here, I will write plus B multiplied by H, and again of this right hand side, that is B multiplied by H. Now collect the similar terms together. If you observe toward this sum, total surface area, then can you see here there is L into B. Again here there is L into B, and again what you can see, here it is L into H and here it is L into H. And what you can say about this BH means, here if you see overall, then here you are going to see the L into B is 2 times. So I will write it as twice of LB plus, again what I will write, again what it is twice, LH is also twice, so I will write twice of LH. Okay, again plus, here BH is also twice, so I will write twice of BH. And from here, if you will take 2 common, then what is left inside the bracket? Here you will get what is left inside the bracket. In bracket you will get L into B, L multiplied by B, LB plus 2 common LH plus 2 common BH. This is the total surface area of a cuboid. Thus you can calculate the total surface area of a cuboid. Now let us calculate the volume of a cuboid. How you will calculate the volume of a cuboid? Like previous, the volume of cuboid is also equal to area of base multiplied by height. Area of base multiplied by height into height. What is the area of base? The area of base of this cuboid, it is a rectangle. This is the base. And its area of base is area number 3. That is L into B. L multiplied by B. And what about the height? Height of this cuboid is H. So like this, simply the volume of cuboid is given by formula L into B into H. In this way, volume of cuboid is always given by formula L into B into H. In this way, you can easily calculate by using an art of mensuration the area, total surface area of a cuboid and volume of cuboid. Okay.